For millennia, humanity has gazed at the stars and pondered life's biggest questions. What are we? Why are we here? What is the nature of the universe? Today, the lines between science, philosophy, and technology blur. We find ourselves on the cusp of groundbreaking discoveries. Our ancestors looked to the heavens for answers. We now turn our attention inward to the very fabric of reality itself. We see the universe through a new lens, the lens of a programmer. This perspective allows us to ask powerful new questions. What if the universe isn't random chaos? What if it's a delicately balanced system governed by elegant code? What if we are living within a grand simulation, a cosmic program designed by an intelligence beyond our comprehension? Join me as we explore these intriguing possibilities. Let's dive deep into the code of existence. Let's see the universe with fresh eyes.
Imagine the universe as a colossal computer program. It runs on a code far more intricate than anything humans have ever devised. This code dictates the laws of physics. It governs the interactions of particles. It sets the stage for stars to ignite and galaxies to spiral. This universal software is constantly running. It processes an unfathomable amount of data every second. Every interaction, every movement, every event is part of this grand computation. It's hard to grasp the sheer scale and complexity. Yet, the universe functions flawlessly, a testament to the elegance and efficiency of its underlying code. Think of the Big Bang not as an explosion, but as the boot-up sequence of the universe. The laws of physics, the fundamental constants. These are the operating system. They define how everything interacts. They dictate the flow of energy and information. Just like a computer program can create virtual worlds, the universe's software generates our reality. Look closely at a snowflake. Notice the intricate patterns, the delicate branches. Each part mirrors the whole, just on a smaller scale. This is the essence of a fractal, a mathematical concept with profound implications for understanding the universe. Fractals exhibit self-similarity. Zoom in on any part, and you'll find the same patterns repeating infinitely. Nature is full of these patterns. We see them in coastlines, mountains, even the branching of our own lungs. This repetition of patterns suggests a deep underlying order. Now, imagine the universe itself as an infinite fractal. Our observable universe, vast as it is, could be just one tiny section of an infinitely larger structure. Each level of this cosmic fractal could contain universes within universes. This concept is mind-boggling but mathematically plausible. It hints at the infinite complexity and hidden depths of our reality. Let's use an analogy from the world of video games. When you play a game, your computer doesn't render the entire world at once. It only renders the parts you can see. This efficient technique, known as just-in-time rendering, saves processing power. What if the universe employs a similar strategy? What if reality, as we know it, is only generated when we observe it? This might seem like a bizarre idea, but it's a serious concept in quantum mechanics. The act of observation, of measurement, seems to play a fundamental role in shaping reality. This suggests that our consciousness, our very act of observing, is woven into the fabric of the universe. We are not passive bystanders. We are active participants in the unfolding of reality. Our observations don't just record reality, they help create it. Quantum mechanics, the study of the very small, is full of counterintuitive ideas. One of the most mind-bending is the concept of superposition. Imagine a coin spinning in the air, neither heads nor tails until it lands. This is how particles behave in the quantum realm. The famous double-slit experiment demonstrates this. Particles fired at a barrier with two slits don't just go through one slit or the other, they go through both slits simultaneously. It's only when we observe the particles that they choose a single path. This experiment highlights the probabilistic nature of reality at the quantum level. It suggests that the universe doesn't follow a predetermined script. Instead, it operates on probabilities, with multiple possibilities existing at once. We can understand these mind-bending concepts better through the lens of software programming. Two dominant models emerge: the continuous processing model and the observer-dependent model. The continuous processing model views the universe as a constantly running program, crunching numbers and updating states regardless of observation. This aligns with classical physics, where the universe ticks along like a clockwork mechanism. In contrast, the observer-dependent model posits that the universe only renders reality when an observer is present. This model aligns with quantum mechanics, where observation collapses the wave function and determines the state of a particle. Both models offer compelling explanations for different aspects of the universe. The continuous model speaks to the universe's consistent laws and predictable behavior. The observer-dependent model grapples with the strangeness of quantum mechanics and the role of consciousness. If the universe is indeed a sophisticated software program, it begs the question, who wrote the code? This is where the concept of intelligent design enters the picture. Intelligent design proposes that the complexity and elegance of the universe point towards an intelligent creator. This creator, often equated with God, is seen as the architect of the cosmic code, the one who set the initial conditions and established the laws of physics. This doesn't necessarily contradict the principles of evolution or natural selection. Instead, it suggests that these processes might be part of the grand design, mechanisms built into the cosmic software to drive the emergence of complexity and life. The idea of God as a programmer resonates deeply with our technological age. We understand the power of code to create complex systems, even virtual worlds. Could God be the ultimate programmer, the one who wrote the code for our universe? This concept offers a new perspective on traditional religious beliefs. It reconciles the idea of a divine creator with the scientific understanding of the universe. God, in this view, is not a supernatural being intervening in the world, but the architect of the very fabric of reality. This perspective also raises intriguing questions about the nature of God. Is God bound by the laws of the universe, or did God create those laws? Can we hack the cosmic code to understand God's intentions? These are questions that science and theology are only beginning to grapple with. As we stand at the intersection of science, philosophy and technology, one thing is clear. The universe is far more complex and mysterious than we ever imagined. Whether we view it as a grand software program, an infinite fractal, or a reality rendered by our own consciousness, one thing remains constant: the search for understanding. The universe operates on principles we are only beginning to comprehend. The more we learn, the more we realize how much we don't know. But this is the beauty of science, of exploration, of the human thirst for knowledge. We are constantly pushing the boundaries of our understanding, seeking the grand algorithm that underpins it all.